Bismillahirrahmanirrahim and Assalamu alaikum. I hope that you all are doing well. This is day 4 in week 3 of class 9 physics, and today we are going to discuss about the artificial satellites and the motion of artificial satellites. So firstly, we need to know that what satellites are, or how can we define satellites. An object that revolves around a planet is known as satellites. Or a satellite is an object that orbits another object. Let's say this is a planet, and the object that is revolving around the planet is known as satellite. We have two types of satellites. First one is active satellites and second one is passive satellites. In passive satellites there are two types: natural satellites and artificial satellites. As we know that moon revolves around the earth, so moon is a natural satellite. Moon is a natural satellite and it is revolving because of the attraction of earth's gravity and by its moon. Second one we have is artificial satellites. What are artificial satellites? This is our main topic. Scientists have sent many objects into the earth, into the space. Some of these objects revolve around the earth and these are known as artificial satellites. So artificial satellites are those satellites which are man-made satellites, and these are sent into the space by scientists. Why are we sending it? We are sending it for the communication purposes, or we can also sending these instruments to perform different experiments in space. Artificial satellites. Firstly, we know that artificial satellites are the objects that are sent into the space, and these objects revolve around the earth, and these are known as artificial satellites. We have different examples of artificial satellites. First one is a Sputnik. It was the first satellite that was sent by a Russian Union in 1957, 4th of October. Next one, example of artificial satellite is Hubble's telescope. It is working right now. Third, we have military satellites. These all are examples of artificial satellites. Now the types of satellites. There are many types of satellites like scientific research satellites. These satellites are used to perform experiments in space. Weather satellites. These are used to know the weather forecasting. Communication satellites. Navigation satellites. Navigation means to find the location. So these operates on aircrafts, ships, lands, vehicles, and even objects. Next one we have our military satellites. It includes weather, communication, navigation, and earth observing satellites used for military purposes. So we have different types of satellites. Some of the military satellites are also known as spy satellites. Next are the uses of satellites. So what are the uses of satellites? We have several uses of satellites. Firstly, we use satellites for weather forecasting, to imaging the Earth's surface. We also use satellites as spy satellites. Next thing, for the scientific research or to perform experiments in space. Next thing we have is GPS, which is also known as Global Positioning System. Geostationary orbits, which are used geostationary satellites, which are used for communication purposes. So firstly, communication satellites. In exams, they can ask you a question as why communication satellites are stationed at geostationary orbits. So communication satellites are basically those satellites which are used for communication. There are a large number of artificial satellites which have been launched in different orbits around the earth. So they take different time to complete their one revolution. Just like we have communication satellites, it takes 24 hours to complete their one revolution around the earth. Let's say it's a communication satellite, it is taking 24 hours to complete its one revolution around the earth. And we also know that earth also complete its complete 24 hours to complete its one rotation. So both are taking the same times. Hence, these satellites appears to be stationary with respect to the Earth. And that's why the orbits of these satellites are known as geostationary orbits. And the satellites are known as geostationary satellites. Why are we saying it as geostationary satellites? Because they appears to be stationary or to be at the state of rest with respect to the earth, because earth was also taking 24 hours to complete its one rotation, and the geostationary or communication satellites are also taking 24 hours to complete it one revolution. So they both are taking the same times, and that's why they are known as geostationary satellites. Next thing is, what is the height of geostationary satellites? The height of geostationary satellites is about 42,300 kilometer from the surface of the earth. And what is its velocity? Because they are moving at the same speed with earth, so its velocity with respect to the earth is 0. As we said that with respect to the earth they are appear to be stationary. Stationary mean rest, and its velocity will be 0. Next question we have is GPS. What do we know about GPS? What is GPS called, or what does GPS stand for? And what is the purpose of GPS? And how many satellites does it consist of? So we will find all these answer here. GPS, it is also known as Global Positioning System. Basically, it is a satellite's navigation system. So navigation means to find the location. It helps us to find the exact position of an object. Either the object is on land or on sea or in the air. So it provides the reliable location and time information of any object that is anywhere in the earth. How many satellites it consists of? GPS consists of 24 satellites. So global positioning system consists of 24 satellites. So next thing is how much time they take to complete its one revolution. So simply they complete their two revolution in less than 24 hours. So if you want to say that the exact motion of the satellites, these satellites revolve around the earth twice a day. With what speed? With the speed of 3.87 kilometer per second. So they are moving around the earth, or they are completing its two revolutions in a day, and with a speed of 3.8 kilometer per second. This is an example of GPS satellite, which is known as Navstar. Next thing is, what is the motion of artificial satellites, or we can also say derive the mathematical relation of orbital velocity. As we know that satellite is revolving around earth in a circular path. So if a body wants to move in a circular path, or it wants to keep its motion in a circular path, it must require a centripetal force for it. And why it's moving in a circular path? Gravitational force of attraction between the satellite and the earth provides the necessary centripetal force. So let's say we are considering a satellite here whose mass is m, and it is revolving around the earth with a height of h, and its radius is r naught, and it is moving with the velocity of v naught. So as we know, to move the satellite in a circular path, or to complete its revolution in a circular path, it must require centripetal force for it. And we know that formula of centripetal force is Fc is equals to mv squared over r. Here velocity is represented by v naught because it's an orbital velocity, because the satellite is moving in an orbit, and the radius is also known as r naught because the satellite is moving in a orbital path. Orbit mean imaginary path. Okay, next thing we have here, if you see that the weight of the satellites will be equals to the mg, because the force which is provided by the gravitational force of attraction between the earth and the satellite is equal to the weight of the body. So Fc is equals to W is equals to mg. We are representing g by gh because the satellite is at some height. So this is also the relation for force, and this is also for the relation of force. By comparing or equating these two equations, we can write it as mgh is equals to mv naught square over r naught. By cancelling m from both sides, we'll get the relation as gh is equals to v naught square over r naught. And when we arrange this equation, we will get v naught square is equals to gh r naught. To remove the square, we will take the square root, and v naught will be equals to under root of gh into r naught. As you see here, r or r naught is basically equals to the radius of the earth and the height. You can see it here clearly that this is r naught, where this distance is r, which is the radius of the earth, and this distance is h, which is the height of the satellites from the surface of the earth. So r naught is equals to r plus h. So we can write r naught is equals to r plus h. So I'll replace, or I'll put r plus h as r naught. Now we get this relation. It gives the velocity with which the satellite is launched in an orbit. Now let's say the satellite is very close to the earth. It is revolving around the earth, but the satellite is very close to the earth. Then what would happen? There will be, let's say that satellite is approximately equal to the surface of, approximately at a height of the surface of the earth. Then there will be no h. So r plus h will be equals to r. And because the satellite is very close to the earth, so gravitational acceleration, which is represented by gh, will be equals to g. So I'll write gh as g and r plus h as r. So we will get the final relation that if a satellite is revolving very close to the earth, so then the relation of the relation for to find the orbital velocity of that satellite will be v naught is equals to under root g r, where g is the gravitational acceleration and r is the radius of the earth. They said that a satellite that is revolving very close to the earth, it has a speed of nearly 8 kilometer per second, or we can say it as 8,000 meter per second, or in hours we will write it as 29,000 kilometer per hour. As we know that moon is a natural satellite. So what is the height of the moon from the surface of the earth? Moon is nearly 380,000 kilometers away from the earth, and it complete its one revolution, or we can say it complete its one orbit in approximately 27.3 days, which is approximately a month. So moon completed its one revolution around the earth in 27.3 days. So they can ask you about the revolution of moon in around the earth and the height of moon from the surface of the earth in MCQs. So that was all for today. Hope that you understand the topic very well. Allah Hafiz.